Well, before I begin, I would like to thank the sponsors of this award, the W.R. Grace Company. Thank you very much. I want to talk today about work that we've done over the past 15 to 20 years on rationally modifying active sites on catalyst surfaces. But before I do that, I would like to acknowledge up front the people that have helped me in the laboratory, more specifically my current and former doctoral students that are listed on the slide, and of course the postdoctoral researchers that have worked in my laboratory. I've been very, very fortunate also to have an outstanding group of collaborators that have decided to allow or to work with me, and I appreciate that. And I do want to emphasize one person in particular on the slide as a collaborator, my colleague in 2005 Emmett Award winner, Matt Nurok. To have someone down the hall who's an expert in catalysis, density functional theory, and to have a good friend in the department is a real blessing for one to have. So thanks again, Matt, for helping out so much. Now, we can't do research in academia without sponsorship, and I've been fortunate to have support from a variety of companies, some of which don't exist today. I do want to acknowledge up front sustained funding from the National Science Foundation and the Department of Energy and Basic Energy Sciences. Those two agencies have really enabled our work to move forward for quite a long period of time. We routinely use the National Synchrotron light source at Brookhaven National Lab, and you see the picture shown there. And so I wanted to make sure that we acknowledge that DOE facility up front. I do want to mention specifically two people with special appreciation. Professor Mark Davis, some of you may know, but many of you don't, is my older brother. When you look back in your life and see how you got to certain places, you find out it's decisions made very early on in your life. And so working in Mark's laboratory when he was an assistant professor at Virginia Tech was one of the early decisions that essentially turned the course of my life. I completed an undergraduate honors thesis in his lab. And you can see it was on the topic of rhodium inside zeolites for catalysis, and essentially that led to the publication of my first paper in Journal of Catalysis. So Mark really introduced me to the area, and 20 years after teaching me my first course in reaction engineering, we co-authored a textbook in the same field. So. But while working in his laboratory and taking courses from him, I learned about another lab at Stanford University, and that was where I decided I needed to be to do my PhD work. So I would also like to emphasize Michel Boudard as a great influence in my life. In 1989, I completed my doctoral thesis with him dealing with supported palladium and palladium gold bimetallics. And by the end of today's lecture, I'm going to show you how we've come full circle and looked again at palladium gold bimetallics. But it's here that I learned the fundamentals of catalysis and materials characterization and relating structure to function. And this is where I first learned about synchrotron radiation methods for characterization of catalytic materials. Now, in 1985, when I went to Stanford, it wasn't clear whether Michel was going to be taking any more students. And so when you look at this family tree, it's a very full tree, but down near the bottom, it wasn't clear that he was going to be able to accept any more students into his group. I almost had to enlist the help of this gardener here to dig a little bit deeper on the tree to get on it. But as you can see, I was very fortunate that Michel accepted me into his group, and we finished by 1989. So what I'd like to talk about today is our work in these three topics. Okay, these are three ways that we've studied over the years to change the behavior of active sites, the reactivity, the selectivity of catalytic active sites. One deals with changing atomic structure, and we're going to look at the example of how titanium and silicon mix together. And then, even though structure at the atomic level and at the electronic level are related to each other, I'm going to try to divide that as well as possible. And by looking at base promotion of ruthenium for ammonia synthesis as an example of electronic promotion of metals. And then finally, I would like to address modifying reactivity by modifying the reaction medium itself. And so this is looking now at supported gold, which is a very topical area. This is our current work in the lab right now, in the aqueous phase. Okay, so it's liquid phase reactions on gold. All right, first, Titanium